Okay, it says Katie, right? A 30 kilogram child. So her mass equals 30 kilograms. Therefore, her weight equals 300 newtons. Okay. Climbs a tree to rescue her cat, who is afraid to jump 8 meters to the ground. 8 meters is no joke. I wouldn't want to jump 8 meters, especially at my age. It's not going to happen. Break your leg. I can see my knee popping. Okay, so the distance is going to be 8 meters. Okay, how much work does Katie do in order to rescue the cat? So she's got to go up a tree, which is 8 meters tall. Okay, yes? So how many meters altogether is she going to go? What is it? Yeah, she's going to go 16 meters. So it's going to be the work equals her weight, which is 300 newtons, times 16 meters. So what's 300 times 16? 4,800?
Yes.
Okay. 4,800 joules. I'm just going to give you a hint of where we're going with this stuff, just for a minute, if I can, right? If you walk a mile, I'm just going to do this on the side. We've just finished number 2. But let me just go a little bit on the side. Is that okay? Yes? Now, first of all, there's a lot of what we would call in science extraneous variables to this. But let's say I walked 1 mile, okay, which is 1.6 kilometers, okay? So I walked 1,600 meters. I walked that, yes? My weight is 100 kilograms times 10. I know we're rounding. It's amazing the amount of people that put notes on my videos that say the acceleration due to gravity is 9.81. Well, it's fair enough, but I'm doing this quickly. Okay, so we're just going to call it an even 10. So my weight, this is the distance, this is my weight equals 1,000 newtons. So how many joules is that? How many joules is that? Right, so it's going to be the work, if I walk that, correct, will be 1,600 times 1,000, which would be what? Work equals what? 1,600 with 3 extra zeros, correct? Right, so it'll be 1,600,000 joules to walk that. Is everybody with me? Yes? All right, now, let me show you something. There are 4.18 joules equals 1 calorie. Yeah, it's true. We're talking about energy, aren't we? I kind of got that through to you, that we're talking about energy, so it's joules. Calories is an old, very incorrect, but very old way to refer to energy. Understood? Calories. We don't really use it in science, but there's a relationship. All right? And we made that relationship okay. But the history of the word calorie is a little bit weird. Anyway, so divide this by 4.18. What do you get? What is 1,600,000 divided by 4.18? Around 300 some, what is it? So it's 382,775. 382,775 calories. Correct? Yes? Now, this is small c. Correct? It's a scientific calorie. Okay? There are 1,000 scientific calories in one dietary calorie. You get that? Yes? So if I'm going to convert this to big calories, how many thousands go into this? 383, right? If I divide this by 1,000, what do I get? You're not really using a calculator. It's okay, it's okay, it's okay. It's going to be 383 big calories. You get it? So, calories, joules, Newton meters, kilogram meters squared per second squared. It's all energy. You know where they say, you know, you'll burn X amount of calories if you do this exercise or if you walk, correct? Yes? Well, that's how it happens. Now, if I run, will I burn more calories or less calories? What's work? What's work? Work is force times distance. A mile is a mile. 1.6 kilometers, I walk it or I run it. Now, not everybody is in shape, so there's a lot of variables here, correct? How many people could just get up right now and run a mile and be okay? No one? How many people could just get up and run 1.6 kilometers, come back, sit down, and not be out of breath? Anybody? I can honestly say that when I was your age, I could do that.
But now,
I can't do that now, not because of my wind, but because of my legs. I couldn't do it because of my legs, but I mean, I could easily, if my legs were okay, I could easily do it. But not, my legs are terrible. But anyway, so there's a lot of variables relative to this. Yes, work is force times distance. You run, you walk, it's the same thing. The problem is how in shape is the person, how out of shape is the person, and the amount of energy that they have to expand, etc. So it kind of falls apart a little bit. It does. But if the question is, how much work do you do if you run a mile or you walk a mile? The time has nothing to do with it. It's force times distance. Clear? Force times distance. Yes? End of next tape.